Hello, and thank you for clicking on my video. If you like my videos, please like and subscribe. That really helps me out. And let's get started. So today's topic is NumPy. It's an open source, freely available library for data and science and math type things for Python. It is very important to know about because if for nothing else, Pandas, which is another library for manipulating data and machine learning, is actually uses NumPy uh, to do what it does. But also, for as a machine learning engineer, you would have to know how to deal with math in your code, and this library is it's really the most popular one that people use. All right, let's get into the coding. So this first few lines coding is just to show you an image of NumPy. No big deal. Let's move on from there. Let me move my video on the side so you can see the code. So the first we're going to do is we're going to actually import NumPy, and we'll give it a name MP. That's pretty common for all coding for NumPy. Now, the thing about NumPy is we could do the same things in list, but it would be super, super slow. But NumPy extremely fast. Why that is, that's a video for another day. But just understand that NumPy is extremely fast when it comes with mathematical operations. For example, in this container that Google is giving us as part of Colab, by the way, I should show you how much RAM it's using. So if I click on that, you will see I have available 12.7 gigabyte of RAM, and right now I'm only using 1.7 of it. And throughout the code, you will see that the RAM doesn't actually change a whole lot. So basically, even though we will be working with a very large array in NumPy, it's still fast, still doesn't take a whole lot of memory. So let me close that out so you get a better view of the code. All right, so let's do this. First, we're going to import NumPy, and then we're going to create an array called X, and by giving it the parameter 1E8, we're saying make a NumPy array that has 100 million elements. When I was practicing for this, sometimes I even got away with 1 billion elements, and sometimes I didn't. So to keep things safe, I've kept it at 100 million elements, but that those elements will be from 1 all the way to 100 million, right? All from starting with 0 to basically 100 million minus 1. So let's create that array, and if we run the shape command on this, it shows us that it has 100 million elements. All right, so what we're going to do now is we're going to run some functions, mathematical functions, statistical functions on this array to show you how powerful this is. So we're going to run these commands. We're going to calculate the mean, median, standard deviation, and we'll figure out what the maximum value of the elements are, and the minimum too. So we run that. It takes maybe a second and a half. And now if you look at the values, remember it went through and somehow, some way, calculated the mean and the median and the standard deviation of 100 million integers. All right. So let's look at the mean, and as expected, mean is right below 50 million, right? Because half of 100 million, because the numbers were 0 all the way to 100 million minus 1. If we look at the standard deviation, we get, I don't know, a huge number, 28 million or something like that. I don't know if that makes sense, but I can do that kind of math in my head. All right, maximum. So if you look at the elements, obviously it went from 0 to 100 million minus 1. So that's numbers 100 million minus 1. Now we're going to do minimum. And of course, the first element in that array was 0. So we got 0, which is the minimum value of the values that it had. Now what we're going to do, we're going to set by using this one little command, and notice our RAM and obviously we're not using disk at all, but RAM doesn't do anything. It doesn't change. It's not using any more RAM than we were using in the beginning of this session, right? So what we're getting from Google for free, we're not even using. So what we're going to do is we're going to take all those 100 million elements and we're going to set each one to 0, right? And then we're going to do the same exact calculations we did before. So we're going to run that. And again, it took maybe a second and a half, right? And and it took no time at all and it just shows you how fast NumPy is, right? So let's look at the mean. Mean is 0. Why? Because every element in that array is now 0, right? Look at the median. Again, 0 because every element is 0. Standard deviation, 0. Maximum value, 0. Minimum value, 0. Now we're going to use another function of NumPy, and there's many functions, and it is so extensively, it has so many things we could do with it. But today I'm going to show you just one fancy thing, semi-fancy thing. So if we're using the random method, we can create an array of our choosing, 100 numbers, and by default it goes from 0 to 1. So let's create that and assign that to y. Now, if you print y, you see you get 100 numbers somewhere between 0 and 1, and it's randomly distributed. So let's see what that looks like. So let's make the same calculation as we did before. Again, this time it took even shorter time, not even a second. The mean of those values is 0.52 right now, which makes sense because we're closer to halfway mark between 0 and 1. Median, we're at 0.48. Again, close to half mark. Standard deviation, what you would expect, is close to 0.25, 0.26. Maximum value, close to 1. Minimum value, close to 0, right? So hopefully you can see in this video that how powerful NumPy is, and I haven't even scratched the surface of what it can do, right? But anyway, you get the idea of how powerful this library is, because if you're doing machine learning, you would be using data science or data analytics. You would be doing this kind of work. You would need to use this library if that's the case. All right, I hope you found this video useful. Again, I thank you for watching my video, and if you like them, please like and subscribe, and leave comments about how to improve or what topic you want me to cover. And I will see you next time.